Yes, myself Gopi. I'm recently internship done with Emertxe Information Technologies Private Limited Bangalore, and I'm worked the project MicroOven using PiximLab. So I will share my internship experience in embedded systems, and I over the past month I worked extensively microcontroller programming, real world interfacing, and embedded applications. So this presentation I will cover everything I learned and the project which I have done. So I am learning the concepts in this embedded system internship. Introduction to embedded systems, embedded system C programming language, and microcontrollers and microprocessors. Project requirements, implementation using MPLab XIDE and Fixing Lab. Yeah, embedded systems. What is embedded systems? The embedded system is combination of hardware and software which is intended to do a specific task that are low power consumption, real-time performance, high reliability, and specific functionality. In this embedded system, we are using the programming language C. Some of the applications or examples are also called washing machines, pacemakers, AC, refrigerators, etc. Here, basics of embedded system C, usage of embedded system C, used in system software, embedded software, OS kernel development, and more. Characteristics of embedded system C, general purpose language and has library facilities. Code format, documentation, preprocessor, statements, global declaration, code, function body. These are the used for the programming. When we are writing the programming, we have to follow these rules: declaration rules, global declaration, local declaration. So data types and number systems, these are integral and floating point, decimal, octal, hexadecimal, binary. Conditional constructs, these conditional constructs are used for looping, that are for loop, while loop, do while loop. These are the more important to execute the code more times, multiple times. The microcontrollers are highly capable of being programmed to perform a task. Has simple design architecture, all components are available in a single chip, and also this less flexible, less design complexity. The microprocessors are highly capable of being programmed to perform any task. Comparatively complex design architecture, peripherals need to be interfaced. This is more flexible for to compare microcontrollers, and more design complexity also to compare the microcontrollers. Here, PIC16F877A board is only used to execute our MicroOven program using this. The operating frequency of the board is 20 MHz. The flash program memory is the size 368 byte. EEPROM data memory of the size 256 bytes. There are 15 interrupts in the board. The input output ports are 5. There are port A, port B, port C, port D, and port E. And also the 3 timers, 2 PWM models. It also has various components like CLCD fan, cocktail switches, buzzer, LCDs, ADC, RS232, and etc. Here, the requirements of the project. The main goal is simulating a micro oven using SimLab, replicating a real-world micro oven. This microcontroller uses PIC16F877A. This is the board of we are executing the micro oven project, and software uses MPLab XIDE, PiximLab, X8 compiler. These three are the softwares we are used to execute the program or project. The project requirements. Uh, First one, MPLab XIDE. MPLab is a proprietary freeware IDE. It is developed by Microchip Technologies. It is being used for programming and development purposes for embedded systems. The version which we have to use for our project is version 5.35. The second one of project requirement is PiximLab. PiximLab is a proprietary free software for simulation of various microcontroller boards are available. It can simulate most of the widely used microcontroller boards like PIC, Arduino, ATM32, ESP32, etc. The components are used in our project: CLCD, fan, buzzer, matrix keypad. The CLCD, it is used to show the results of project and it is act as a screen of PiximLab. Fan, the fan is used for cooling purpose of the MicroOven heated pot. Buzzer, buzzer is act as alarm. It is used for timer of the project. That also required time. It acts as alarm. Matrix keypad is the keypad is used for enter the values of the MicroOven working time and letters are also here. PiximLab board look like this. This is the screen LCD display. Is this fan? This is buzzer, and these are the matrix keypad switches, and these are the LEDs. The project overview. The project name is MicroOven, and document type is requirements and design document. Version is 0.1. Organization Emertxe Information Technologies Private Limited. The purpose of the project is validate and review requirements of MicroOven, and the scope is reheating and cooking food using different modes like grill. So system block diagram components are 5: microcontroller, CLCD display, matrix keypad, fan and buzzer. And the functional requirements of the project, and also called the modes, that are power on, message, cooking mode selection, macro mode, grill mode, convection mode and start mode. And start mode defaultly set the time 30 seconds. The mode is macro mode. This is sets the cooking time from users. Displays power level and start, pause, resume, stop supported. This is the user interface. A grill mode. This is the second mode. This is also user sets cooking time. This is purpose of heating. This is also component start, pause, resume and stop supported. The convection mode is the another mode of the our project. This is user sets temperature, preheating phase, user sets cooking time, full control operations. This is the convection mode. Temperature controls in this mode. The start mode is the last mode of the our project MicroOven. This is default cooking time is 30 seconds. Each press adds 30 seconds. This is also have pause, resume and stop supported. The user interfaces are CLCD screens, mode selection via keypad, time and temperature entry, status display. The CLCD screens are used to see the screen. The mode selection via keypad is the our selection through the process of MicroOven. The time temperature is also be our own. And finally, the conclusion of this project: complete MicroOven simulation and cover all basic cooking modes, and user-friendly keypad interface. The embedded systems are widely used across industries such as consumer electronics, automotive, healthcare, industrial automation, and telecommunications. By offering real-time performance, low power consumption, and compact design, embedded systems enable smart and intelligent devices that improve productivity, safety, and quality of life. Thank you. Now we see the demo of the our MicroOven project working. So powering on machine, we load X file, load X microoven.x, open it, and powering on microoven machine. That is the display, and we can see the four options: micro mode, grill mode, conventional mode, and start mode. Now firstly we can open the micro mode. Whenever we can open the micro mode, press 1 to go the micro mode. So we can press 1 to go micro mode. Powering on 900 watts, we can set time machine, that is in the form of minutes and seconds. That's minutes, that's seconds. So uh, we can enter the values. 1, we can enter the 1 minute 10 seconds, right? We can enter the star, clear the values. We can enter the hash, enter the, we can type the value is right. So press the enter, the process will be continue. Clear and hash, press hash. The process will continue until the timer will be 0. The fan will moving on until the timer will go to the 0. We can press 4 start and resume. We can press 5 pause, 6 stop. We click the 5 and stop the fan, and we click 4 resume. So and fan is stop. Also the process all enter the process is stop. If we can press 6 and we are go to the home, press 2 grill mode, that's also we set time, as well as the grill mode also, as well as the micro mode, and this is also meters and seconds. We can enter the 15 seconds. This is also same as micro mode. Fan will be going on until the 0. We can press 6, go to the home screen. Next we can go to the convention mode. convention mode, press 3. In this mode, we can see the temperature in the Celsius. So press 120 120 seconds. In this convention mode, inbuilt have the 13 seconds. I mean 60 seconds. Sorry, 60 seconds preheating time. That is inbuilt of in this micro oven. Time is going to be 0. And finally, for start mode. Start mode also inbuilt have 30 seconds. That's going to cool the heater part. This is also P3. Start resume, pass and stop. 456 enters. These operations are performs. So this is the operation of micro oven. Thank you.